I want to talk for just a minute about Coulomb's law. And this law is the force on a charged particle is equal to the constant K times the charge of particle 1 times the charge of particle 2 divided by the distance between them squared. And it might seem like one of those things, why do we really care? We're talking about such small stuff. But when we have these particles, sometimes we know that something has a charge because it's attracting or repulsing other things, but we don't know the amount. So we can use what's called a test charge, and that's a charge whose amount of charge we know exactly, and we can put it near our unknown charge. And if we know this distance, and we measure the force, then we can find the charge over here. It's also important to realize that it's not always just two charges. If we have this charge here that's positive, in some amount that we know, let's say 1.67 microcoulombs. We have a charge over here that's also positive, but this one's bigger, so it's 4.21 microcoulombs. And we can use Coulomb's law to calculate this force between them. If I had another charge down here that was negative, and we know because these are both positive, the force on each of them would be away from each other. But if we put a third charge down here that's negative, and maybe it's the strongest of them all, we know that on this particle there'll be the force going this way and a force going this way. But using vectors we can add to find the total force. So we would use Coulomb's law for both forces individually, and then use our vectors to calculate the total force. And over here would be the same. It would have this, and it would have one like this, which we could still use vectors for, because we could take this force and break it into x and y components, and then add it to this x and calculate it out. So realize that while this is fairly simple, it can be more complicated. We could talk about more than one charge at a time. And in many situations, we are talking about more than one charge at a time in real life situations.